Welcome to the rest of your transformations of functions continued notes. In class yesterday, we did number 3 and most classes did number 6 as well. So we're going to do the remainder of them on this video. And then I'll do a few examples from this accompanying assignment as well. Number 1. If f of x equals x, then 2 times f of x equals. So we're not replacing x with anything, but we are just multiplying the entire function by 2. So my entire function, my rule is x. It's my function rule. So I'm just taking 2 times that, so I have 2x. Then you can kind of compare what is happening here to the function with our summary rules up here. So we're multiplying the function by a number out in front. So I know that's going to be one of these things, either a stretch, a compression, or a reflection. And since this number is greater than 1, so 2 is greater than 1, of course, then I know it's going to be a vertical stretch. So for transformations, I'm going to write vertical stretch. And then I'm going to draw a graph. So f of x equals x is this one. And then 2x looks like this. So you can kind of see that it's been stretched upward. It's a little bit steeper than the original. Example 2. If g of x equals x squared, then g of x plus 2 equals. So this time I'm replacing x with x plus 2. So instead of saying x squared, I'm going to say x plus 2 squared. So x plus 2 squared. And then my transformations, I can look up here and I can try to figure it out, or I can go ahead and graph it and I can tell that way. If I look up here though, I notice that I'm in the parentheses, so I'm inside the parentheses, and I'm taking x plus 2. So it's going to look like this one. So that means I'm going to be moving left 2. So I'm going to translate left 2. And then I'm going to go ahead and graph that. So this is the quadratic parent function. Like this. And you could put this in your calculator or look at my blue function board if you're not sure. I'm sorry, that's really messy. And then this one, if I were to graph it, would look like this. And again, you could check that on your calculator if you weren't sure. So this is g of x, and this one is g of x plus 2. Number 3 should be done. There it is. If you need to pause it real briefly to get it, you can. And then 4. So number 4, if g of x equals x squared, then negative 3 times g of x equals what? So again, I'm not replacing x with anything. I'm just multiplying the entire function by negative 3. So I'm just going to take x squared times negative 3, which is negative 3x squared. And then I'm going to go ahead and graph that. So my parent function is like this. So my parent function looks like this. And then my transformed function is going to look like this. So I'm going to show it to you. It looks something like that. So my transformed function looks something like this. So I can tell that it is upside down. So there is a vertical reflection. And then it's also skinnier and kind of stretched looking. That's at times 3. So there's also a vertical stretch. So that you could also compare to the front. So now there's a -3 in front. So the 3 fits here, that's your vertical stretch, and the negative is your vertical reflection. So you have both of these, vertical stretch and vertical reflection. Number 5, we're again starting with our quadratic parent function. You know what, let me go ahead and draw that one. I'm going to keep drawing it messy. Then I'm just taking my function, I'm not changing x at all, but I'm subtracting 2 from the end of it, so it's just going to be x squared and then minus 2. And if you were to graph that, you would see that it moves down, so it looks like this. Oops, those are wrong. Right there and right there. Sorry. Like that. So this one moved down 2. And if you want to check any of these on your calculator, you're welcome to. All you have to do is this. Let me show you on this one. So all you have to do is go to a new document. Add a graph page. And then type in your first one. So type in x squared. And then press tab to type another equation. And then type x squared minus 2. And there you can see it. Looks just like that. Except that's pretty and that looks really messy. Hey, close enough. Now, if your class did not get number 6 yesterday, here it is. Notice it's kind of got number 3 in it. There's what number 3 was. It also has a +5 at the end and a minus sign in front. So you've got right 1, that's this, tells you right 1. So you can see it moved right 1. Up 5, so 1, 2, 3, 4, 5. And then vertical reflection, so it's upside down. Number 7, as 7 through 10, actually, you're doing the same thing, you just don't have to draw it anymore, but I still recommend looking at the graph if you feel like you're confused at any time about what's going on. So number 7, if f of x equals the square root of x, then f of x minus 2 plus 3 equals what? So what you're going to do first is replace x with x minus 2. So instead of being square root of x, it's going to be square root of x minus 2. And then that plus 3, since that's outside the parentheses, is just going to go at the end. So plus 3. So I've written the equation, and now I have to name the transformations. And I'm going to actually go ahead and graph this for you. I'll show you how to graph it. So square root is right here. So control x squared. So then type x right there. There's your parent function. That's this one. And then press tab. And then again, square root of x minus 2. And then you have to press the right arrow to get out of the square root so that you can type plus 3. So then you can tell it goes right 2, 1, 2. There's your right 2. And it went up 3. So here's your up 3. 1, 2, 3. So right 2, up 3. Next one if g of x equals x plus 2, then negative 4 times g of x equals. So notice we're not replacing x with anything. We're just multiplying the entire thing by negative 4. So you're going to do negative 4 times, and put this in parentheses, x plus 2. Now linears are always a little harder to tell from the picture, but you can still graph it. So type x plus 2, then tab, and then negative 4 times, parentheses, x plus 2. And you can see it is reflected, so it's going the other direction now. Instead of being positive slope, it's a negative slope. So it's a lot steeper, so that's a vertical stretch. So we have a vertical reflection and a vertical stretch. Notice I didn't say anything about the plus 2. That's because it was part of the original function. So when you compare this one with that one, they both have the plus 2, so you don't have to worry about that as a transformation. Number 9, if h of x equals x squared minus x, then h of 0.5x minus 1 equals. So first we're going to replace x with 0.5x. And then at the end we're going to do minus 1. So instead of x squared, I have 0.5x squared. And instead of minus x, I'm going to do minus 0.5x. And then at the end, I'll put minus 1. So let's graph that. So here it is. The blue is my original. And it's kind of like a rust color, whatever it is, reddish anyway, is the transformed one. So original and then transformed. So we can see it move down 1. And in fact, there's down 1. Now something else happened to it that we didn't talk about on the notes, and it doesn't come up very often on Algebra 2 either, but if you notice it is wider, so it got wider, and that is called a horizontal stretch. And you won't see this too often in this class. It'll almost always be vertical stretches and vertical compressions. Speaking of which, look at number 10. If n of x equals x squared, then negative 0.25 n of x equals. So again, we're not messing with x. We're just taking the whole function and multiplying it by negative 1/4. So negative 0.25 times x squared, and that's your transformed function. So let's see what happened to it. Check it out. Here's our original, the quadratic parent function, x squared, and here's our transformed function. So you can see it is upside down, so that's a vertical reflection. And it's also gotten squished this way, it's shorter. In fact, let me turn over the paper and point out that 0.25. So remember this, if you're looking at the number that gets multiplied in front, if the number is between 0 and 1, that's a compression, and if the number is negative, it's a reflection. So in this one, we have a vertical compression and a vertical reflection. So vertical reflection and vertical compression. So this goes in your notebook. Put this in your notebook right now. Pause the video and put it in your notebook. Then come back and we'll do a few of these. So I want to just do a few examples with you on this assignment to make sure you understand what to do. So these are like your function notation notes. In fact, I'm going to write that up here. Your function notation notes, that's the front. And then the back is like your pink ones that you just did. So your first set, evaluate each function. So like 1 through 10, evaluate each function. So remember that this number here, so if I have p of t equals 4t minus 5, and I want to find p of negative 10, remember you replace your variable with the negative 10. So that gives me, instead of 4 times t, I have 4 times negative 10, and then minus 5. And just stick that in your calculator and see what you get, and you should get negative 45. And that's all there is to that one. So 1 through 10, that's what you're doing. Just plug the number in for the variable and get the answer. Yay. Okay. 11 through 20 is what you did on your function notation notes, but also what we were doing here. It's exactly the same thing. You start with a function, and then you replace the x with something maybe, or add something to it or whatever. So number 11, if w of x equals 3x minus 2, then find w of 3x. So I'm replacing x with 3x. So instead of 3 times x, I have 3 times 3x. And then minus 2. And try to simplify that a little bit if you can. Like, I know that 3 times 3x is 9x minus 2. So that's what it would look like. Or let's find another one. Let's just do 12. So I have p of n equals negative 3n plus 1. And I want to find p of n plus 1. So I'm replacing n with n plus 1. So instead of negative 3 times n, I'm going to have negative 3 times n plus 1. And then there's another plus 1 at the end. And then again, if you can simplify it, go ahead and try to do that. So negative 3 times n is negative 3n. Negative 3 times 1 is negative 3. And then plus 1. And then negative 3n minus 2. So that's 11 through 20, just like that. Finally, on the back, please write down that your parent function is y equals x squared. So you're comparing all of these to x squared. So compared to x squared, for instance, this one has a lot of 2's in it. So you're doing it just like this. So x minus 2, well, look on here. Well, that kind of looks like it, x minus 2. So you're going to be going right 2. Then this one at the end, well, adding or subtracting a number to the end, that's this. So we're probably going to be going down 2. Then in the front, I have times everything by negative 2. So times the function by negative 2. So the negative number in front is a reflection, so vertical reflection. So bullet points. And the last one, times 2, that's this one. 2 is greater than 1, so that's a vertical stretch. So now we're going to graph this and just make sure we got it right so that we can sketch it. So I'm going to graph my original, my parent function x squared. And then I'm going to graph the transformed function. So looking at those, you can tell it's vertical reflection. It's upside down. We can see that. Then for the vertical stretch, it does look like it's been pulled this way because it's a little skinnier. This one's skinnier than that one. It did move down 2, so 1, 2, there it is. And it did move right 2 as well, so 1, 2, there it is. So I'm going to sketch that one. So if you want to view the grid lines, press Menu, View, Grid, and I want a line grid. So it's just a little easier to see sometimes, so you can sketch a graph. Oops. Well, I tried. All right, there. Good enough. So go ahead and try the rest of these on your own or with a partner, and then please turn them into the sub at the end of class. And if we need to, we'll look at it again on Monday when I get back. Thank you very much.